Texas, USA. Home to big stuff. Big cows, big boots, big hats, big mustaches. But Texas is also the birthplace of a miniaturized miracle, the silicon chip. And here in Sherman, 20 miles north of Dallas, is the MEMC fabrication facility. In this strange, futuristic-looking plant, they produce silicon wafers, which are the basis for all modern microchips. Silicon has special properties because it's what's called a semiconductor. That means that depending on how it's treated, silicon can either conduct or block the flow of electricity. It's this property that makes it ideal for supporting the millions of tiny transistors necessary for a modern computer chip. But because these transistors are so incredibly small, the silicon base on which they rest needs to be absolutely flawless. It took decades to perfect the process of producing silicon with a perfect monocrystalline structure. They begin with raw polysilicon, or poly, and heat it to over 2,500 degrees Fahrenheit inside a special sealed furnace, which has been purged with argon gas to eliminate any air. The resulting lake of molten silicon is then spun in a crucible, and a silicon seed crystal, roughly the size and shape of a pencil, is lowered into it while spinning in the opposite direction. As the molten polysilicon is allowed to cool, the seed crystal is slowly withdrawn at around 1.5 millimeters a minute. The result is a single silicon crystal weighing around 440 pounds and with a diameter of around 200 millimeters. The crystal is so strong its entire weight can be supported by a single thread just 3 millimeters across. But it is brittle, and it must now be cut down to size without shattering. After testing with chemicals and X-rays to check its purity and molecular orientation, it's fed to a silicon salami slicer. This 10-ton wire saw uses a fast-moving web of ultra-thin wire to produce wafers of silicon that are just 2/3 of a millimeter thick and 99.999% pure. Once cut, there are microscopic marks left on the wafer surface, so it's time for a buffing using a process called lapping. After a twirl in this high-powered polisher, they are still not smooth enough, so they're given yet another buff using a chemical process. The result is wafers of silicon with a surface roughness of less than 1/millionth of a millimeter. Buffed to a sheen, they're finally ready for etching with the circuit design.